Are you sure it's right? Okay. So you agree with yourself the first time. Okay. How did you measure this one? Did you just use your fingers or did you use the ruler?
Just use
Okay. So now, so that was area. Right? This one perimeter. Now you've done some measuring already. Right? Now which one has the smallest perimeter? Which one has the next smallest, the next largest perimeter? Put them in order. So these were area, this one is perimeter. How are people doing with perimeter? Which one has the smallest perimeter? Number two?
Yeah.
So that's the third task, right? Your first task was to, again, first task was to just use your eyes on the area. Second task was to then use a little bit more care, but no rulers. Try to see if can you change your mind at all. And then the third task, your third job, is to measure the perimeters. And there you can use the rulers to measure the perimeter. Perimeter is the distance around. Right? And we're using centimeters, so make sure you're using proper units, like centimeters. So don't just put 5, put 5 centimeters. Right? That's okay. We got time. We're not in a hurry. Oh, yeah. What were your units? These are centimeters. Make sure you put centimeters on here. So let me ask you a question. On some of these shapes, do you have to measure all the sides?
No.
Or can you just measure some of the sides?
Yeah.
Okay. So make a note of that. Look at what, some of those shapes, you don't have to measure all 4 sides or all 3 sides. Maybe you can already tell some information without having to remeasure all the sides. So that may be a quicker way of doing that. Once you have your sides, then how do you find perimeter of these shapes? Add the sides together, right? You get them all?
Yeah, but I got the number.
The same? It might be. It's possible. How did you do your measurements? Did you use a ruler for that?
I use the ruler because here is 5, right?
Yep.
So I know that's 20.
Yeah, so go ahead and write that on here. Right? So make sure, you can write on this. 5 what? 5 what? Centimeters, yep. So we want to make sure we're using units. And so then you said perimeter was 20, right? So you can write P for perimeter equals 20 centimeters. And I did that for the other ones as well. That way you can make sure that you have the right.
Okay.
Yep.
This one 23, right? The outside. The outside. So
11.2. Yeah, 11.2 is a good estimate. Yeah. So you just perimeter.
10, 20, 25.
You're doing that right.
Okay.
1, 6, 5, 2, 4. Got it? You got it. So then you have. Yep. It doesn't match with the area. No. Should it? Should the perimeter, your list of perimeters match the list of areas? I don't know. Good. It might. It might. Is that 11?
Area, they have a like different formula, right?
No.
We'll talk about that in a second. Yeah. Yep. Yeah. Who's ours? Space that for? Tricky, yes. So, all right, let's kind of come back to. I think most people are kind of in the same spot here. I'll get settled here. So we're just looking at the first 6 shapes, and let's put down some measurements here. I'll record them on the screen as well, just so we have them. Make sure everybody's on the same page. So for number 1, that is our square, right?
Yes.
And what are the dimensions? The word we use is dimensions. What are the dimensions of the square? Dimensions means the measurements, right? Means the measurements. What are the measurements of the square? What did you measure? How much did it measure?
5.
5 what? 5
centimeters.
You use one of these, right? Yes. So what did it measure? 5 centimeters, not 5 inches, right? 5 centimeters, right? So it's important to use labels. Okay. All right. Let me choose a color here. I'll choose blue. 5 centimeters. And because this is probably most likely a square, we don't need to measure all 4 sides, right? So what we'll do is we'll put little tick marks to show that these sides all measure the same. Fix that one. Okay. And perimeter then would be equal to 20, right? 5 times 4, or 4 times 5 will give us a perimeter. I'll just write it as P. P equals 20 what? Centimeters. Right? Okay. And let's repeat that for number 2, for the triangle. What did the triangle measure? 5 centimeters along the bottom. Right? It's also 5 centimeters along the other side. Right? So again, I'm just going to go like put little tick marks like this to show that they're equal. They're congruent. Again, we're using the geometry word congruent. But how long is the other side?
7.
About 7, right? It's a little more than 7, but 7 is close enough for what we care about. Okay? So now we have, for this one, we have a perimeter of 17. 17 centimeters. 5, 5, and 7. Okay? All right. Let's go down to number 3. What are the measurements, the dimensions for number 3? 5 and 10. So 10 centimeters long, right? And 5 centimeters high. Okay. Again, these are the left side and the right side are congruent. The top side and the bottom side are congruent. I'm going to use a different set of tick marks. I use a double tick mark for that because if I just use a single, it'll show it's the same as the 5. So I have to use a different system there. What is the perimeter of this rectangle? 30 centimeters. And how did you calculate 30? What way did you do it? 10 times 2 plus 5 times 2? Or 10 plus 5 times 2? Would that work too? All right?
Yeah.
There's different ways you could do it, right? You could do 10 and 10 is 20, 5 and 5 is 10, 20 plus 10 is 30. Or you know that you've got double side, the sides are double. 10 plus 5 is 15. 15 times 2 is still 30. So you get 30 either way, right? Okay. Number 4. What does number 4 measure? 10 and 7. Okay. 10 centimeters.
I have a 7.1.
7.1?
Yes.
Yeah. It's not exact, teacher.
No, it's not exactly.
Yeah,
It's not exactly
you
7.
could
But
try.
I think, but is it 7.1 or 7 or 7? What do you think is closer?
7.1.
7.1? Do we agree? So how many people? What do we like? 7 or 7.1? 7.1? Okay. So let's go with 7.1 because it actually is a decimal. It's not a very nice number when we actually calculate it. So I think that could be the same for the one up here as well. So 'cause what we'll find is the same measurement.
But that one is like 7, teacher.
If you look at it more carefully, you'll notice it's the exact same length.
Same one.
It's the exact same length. Yep.
7.1.
And that'll be important later on. We're going to talk about area on these in a minute. So again, do we need to measure the other two sides?
No.
No. No, because this side measures 10, the top side measures 10, the slanted side measures 7.1, and the opposite side measures 7.1. I'll use 3 little tick marks there. And so our perimeter becomes
34.2.
30. If we use the 7.1, we get 34.2, right? 34.2 centimeters. Okay? Now, how about number 5?
Why?
We've got 3 sides again.
5.
The short side, the short leg is 5, right? So that's that side. That's that side again. Same length as the others.
The straight one is 10.
The height.
The height is 10.
Height is going to be 10. I'll use the double tick mark again and write 10 centimeters. And the slanted side is called the hypotenuse.
11.2.
11.2, 11.1, 11.3.
I do 12.
12? Is it all the way to 12? It doesn't go all the way to 12. 12 is actually too long. I'm gonna double check here. Let's just double check.
11.1.
I can't really do it on the screen because that's a little bit bigger, but then it could be 12, right? Let's see. I'll try this again. 11.2. I see 2. Yeah. I think it's technically 11.18 if you actually do the actual math with it. I think it's 11.18, but these rulers don't do it like that. So we'll go with 11.2 because that's a good estimate. 11.2 centimeters. And that gives us a perimeter of how much? 26.2 centimeters. Oops. All right, and finally number 6, the isosceles triangle. Isosceles triangle is 5 centimeters on the base. We can call that the base. For an isosceles triangle, that is the base. Again, I'm going to use one little tick mark there. And how about the legs? These are called the legs.
10.4.
10.4? 10.3? 10.5? Oh my gosh, you guys are all over the place here. Let's see. Let's see, I'll try this again here. 10.5. Well, you guys are way over if you're 10.5. 10.3. 10.3. Yep. I think the actual measurement is like 10.301 or something.
10.4. You measure in the middle or the curve? 10.4.
4, teacher.
Do you measure the maybe 3 or 4?
Oh, 3.
3?
3.
3.5, teacher.
3.
Go to 4.
We'll go with 10.3. 10.3. That's fine. Right?
Don't be dirty.
Hold on, we'll do a little bit of calculation. I'm going to do the calculation in secret here rather than putting it up on the screen. Sometimes I put it up on the screen. This time I'm going to do the calculation in secret. Alright, so we have,
Okay, now let's see which one is
so we've got that one, 6.6.
17.
Then, yeah, the actual number is 10.307. 307. This is not close to 4.
That's not nice number.
Yeah.
No, they're not. They will not be nice numbers. No, because they don't come out that way. So 10.3 is a good. Okay,
You
so
want a fancy number, too.
you want the fancy numbers? We don't need to throw the extra square roots and stuff that actually goes out with this. What's the perimeter? So 10.3 gives us a perimeter of 25.6 centimeters. Okay. Because this side and this side are congruent to each other. All right. So now we've got the perimeters for all of these. We'll zoom out here a little bit. Okay. Which one's the smallest?
2.
2. Which one's next?
1.
1. So 2 and 1.
6.
2 and 1, and then 6. 5.
3. 4.
3 and 4. All right. Is that the same order you got for area?
No.
It's probably a little different, right? Okay. Save this here just so I can save it and then close it again.
Everything is
10,000 what?
10,000.
10,000. So down to the nanometer? You can measure them down to the nanometer if you want. Alright, so I'm going to close that. I did save it. I'm going to open it again here. So we have it recorded. Now we're going to switch over and we're going to talk about area. You remember, so you guys have worked through the Khan Academy practice already.
15 divided by...
Well, except for Meech, but she did it like last year, so. No, I'm teasing. Let me close this one. I'm going to open it back up as a blank one now again. We're going to look at area.
Yeah, 25.
25?
All right. All right. So let's take a look at the area. Now you've done the measurements now.
How about this one?
You've done measurements on these. So what's the, and you did your eyeball estimation,
They divide it by
Right.
10.
and you did your finger pencil measuring to see about area. Now we're actually going to use the rulers, but you've already got some measurements already. You went through and measured things already. So again, so let's look at the square. The square has measurements of what now? It's 5 centimeters, right? And each side measures the same, right? So in this case, we're going to figure area. And area of the square is how much?
25 centimeters square.
And how do we get 25? Why is it 25, not 20?
Divide high and
Multiply.
you have to multiply.
Okay. You're multiplying one side by the other side, right? Why does that work? Why does that work? And why do we say square centimeters? So there's two questions there. Why does multiplying, with perimeter we added, but with area we're multiplying, why does that work?
All the same size.
Well,
Small thing fit in the.
we're saying this is 5 centimeters, right?
Yeah.
So that, what we're saying then is, if we go across, if we have 5 centimeters here, what we're saying is we've got 5 rows that are 1 centimeter high, right? 1, 1, 1, 1, and 1, right? And the same thing going across. We've got 5, 1, 1, 1, 1, right? 1 centimeter each. Well, what's this? 1 square, right? How big is that 1 square? 1 centimeter by 1 centimeter, so together we call that a square centimeter. 1 centimeter square. We put a little second power on the centimeter because it's centimeters times centimeters, right? How many squares are in that? 25. 25. So that's why multiply works really well. We just take 5 times 5 gives us the 25. That way we don't have to count up all the pieces. But this is why multiply gives us area. And so we should say 25 square centimeters. Also change that to here. Centimeters square. We put a little 2 on the centimeters. Right? If we used inches, we would do the same thing. However, I think the inches might come out with a fraction on there. Let's go to number 3. Before we do the triangles, let's go to the rectangle in number 3. So the rectangle was how much? Was 5 on the side, right? And 10 across. All together, that's going to be 50 centimeters squared, or square centimeters, right? If we were to draw, we'd have 10 columns and 5 rows, right? Did we talk about rows and columns last year? I think we did, right? So that's what we're counting. We're counting how many little squares, just like on the ceiling. How many squares are on the ceiling? We could use those in feet or inches or centimeters, or we could just say a square. All right. Let's do the easy ones first before we get to the difficult ones. Let's go back to number 2. Do you remember how to find the area of a triangle?
This one, we did it. You have this one.
So I hear people saying about base times height times a half. Base times height divided by 2. Why is there that divide by 2 in there?
It's a half of square.
Half of what? It's half of the square, right? So this, because we said that this measures 5 and 5, right? So it's the same measurements as this rectangle, or as this square. So if this is 5 and this is 5, do we really need to measure things again? Do we need to really do any multiplying? We already did it there, right? But this is half. If we cut this in half diagonally, we can just do 25 divided by 2, right? So save us a little bit of time. So again, these sides are congruent, so we can just do 25 divided by 2, and we get an area of, I'll put it right inside here. Area equals what? 12.5, right? 25 divided by 2, 12.5 square centimeters. Okay. Questions on that one?
No.
Why do we divide by 2?
Because only half of the square.
It's half of this square. It's the same measurements. It's 5. That's why I put these little marks on here to show it's all the same measurement. I don't want to have to write it all over again. That's a lot of extra writing. So, okay. And this is just half of that. For number 3, we have that rectangle. Is there a do we have a shape that's half of that rectangle? Which shape is half that rectangle? It's number 5. Number 5 looks like it's about half that rectangle, right? What's the measurements on number 5? 5 and 10, right? Isn't that the same thing as number 3? 5 and 10? Right? It's just turned on its side? Right? So to find the area for number 5, we can just take number 3, divide by 2. Right? So it gives us 25. Yeah. So again, so this is one mark, this is double mark here, double mark, single mark. So on the number 5, we're going to do the same thing. Single mark, double, oops, try that again. Double mark. I'm not going to bother writing measurements. I'm just using the marks to tell me that these are the same measurements. So 10 times 5, divide by 2. So we get an area of 25. 25 centimeters squared. Okay. Yep. Oops. Hey. Go up. There we go. Okay. We okay on that one?
Yes.
Okay. So perimeter, let's say perimeters, we said 2, 1, 6, 5, 3, and 4. It was our perimeters. And our areas. All right, what do we have? What do we have left? 4 and 6, right? All right, let's take a look at number 4. How do we find the area of number 4?
Teacher, what's the formula of perimeter?
Oh, let's figure it out. If I just give you the formula, then you don't get to think about it.
Is the same as
Let's think about it. So we've looked at the triangles, right? It's you take base times height, which is the same as a rectangle, divide by 2, right? But for a parallelogram, how can we do that?
Base times height.
Some of you might know this already.
2 base, teacher.
Let's take. What did you measure? You measured the base,
The base.
right? Which is 10.
Yes.
10, right? And you measured the angled side here. But will this side help you with the area?
No.
No, remember we want to know how many rows and how many columns. But the problem is we've got pieces here. So that's not going to help us too much. We don't want these little pieces. We want to find a nice way to give us that area without a lot of extra work. How would you do that? Any ideas? Some of you know the formula. Why does so those of you who know the formula, why does that work? I'll ask you that question. You're going base times height, base times height. Why is that? Why does that work?
Yeah, you have to cut that one and connect to each other.
So you're saying cut?
Yes. And move that.
So if you take this, cut that off, and move it over here, what do you have? The same as number 3, right? So now you just have to know what's that height? What is that distance? What is this piece right here?
5.
And you can measure that. You have your rulers.
Yeah, 5.
It's 5, right? Okay. Maybe you measured it before, but now you can measure. You go, oh, that's 5. So it turns out. That yes, this is still 10. This is still 10. 10 centimeters here. But then we have this. This is our height, and our height actually measures 5 centimeters. Because it's like taking this triangle piece and moving it to that side. Okay? And what do we get for an area? 50. We get the same as the rectangle. They did this on purpose. They gave you these measurements, these shapes on purpose.
I don't understand. If this one is 5, this one is 7 on 1. But you take the 5 and fill it.
No, you're not tilting it.
If we,
No, you're cutting.
You're
You're taking this piece and you're moving it over here. So it's like you have, okay, and you could do this. Some people, I heard somebody say talking about cutting it to square. You could do it like this too, right? So you have this square, which actually would measure 5 by 5, right? And then you take this piece and this piece, the 2 triangle pieces, and put them together, you get another square, right? So that's how you can prove. That's how you prove that it's base times height. Just by going, I could take these pieces, cut them apart, and you could do this with a pair of scissors. If you had a pair of scissors, you could cut that apart and prove that it works. No, that's not going to help you with the area. It makes it more complicated. Which is why we just do base times height. If you can measure the height and you know the length of the base, you have it. It works just like a rectangle. Okay. Finally,